Hi, this is David Turtle. Welcome to video 4C, which is the third of 5 videos in total devoted to the topic of valuation and risk models in the Part 1 FRM for 2012. And that means that we have 4 of the chapters from Bruce Tuckman's Fixed Income Securities. These chapters reappear and have been in the FRM for several years. The second edition has recently been revised to the third edition, the first new edition in about 10 years. But as of 2012, we're still assigned the second edition. This will probably be the last time. And these are very solid introductory chapters to fixed income securities. So highly testable, highly relevant to a Part 1 FRM candidate. And in regard to the learning spreadsheets, I've consolidated. I had 5 last year, but we're tightening that up to 3 learning spreadsheets, 4C1, 2, and 3. 4C1 illustrates the discount function and a couple of applications there. It's a workbook, but only of median relevance. And then 4C2 and 4C3 I tagged as both highly relevant, and these are really core building blocks for the asset class that is fixed income securities, and that is 4C2. The illustrations with the spot and forward rate curves, very central to the bond or fixed income securities asset class. And 4C3, duration, a workbook, several sheets. Duration is the key single factor sensitivity that we use for bonds and fixed income instruments. So those are very foundational to the FRM. So chapter 1 is introductory. What is it introduces the time value of money and asks the question, what is today's fair price of $1,000 received in 1 year? And Tuckman makes 2 points basically. The first is that as individuals, you and I can assign different values to that today. I can decide that $1,000 in a year is worth $940 to me, and you can decide something different. However, and this is the second point, and really the more important one for our purposes, there ought to exist only one market price for this future $1,000. Quote, is the collection of these individual decisions that determines the market price for $1,000 next year in the first place. And now, so this time value of money concept and discounting, a couple of useful terms, tools if you will. The first is the discount factor. Notice the notation here, D of T. This gives the present value of 1 unit of the currency to be received at the end of the term. So, for example, here's D of 6 months, or the discount factor for 6 months, or probably just best to say the 6-month discount factor. And so notice it's 0.97557. It's going to be less than 1 and get a greater than 1, 0. Between 0 and 1. So that means, what does this 6-month discount factor mean? It means the present value of $1 to be received in 6 months is 97.557 cents, in other words, $1 multiplied by our 6-month discount factor. And similarly, if that means if A pays $1.05 in 6 months, given that same discount factor, we can determine that it's worth today 102.43. So it's just a number that we use to multiply that future value by to get today's value. But it's really handy because it may be hard on first introduction to appreciate the elegance of the utility of the discount factor, but something that it does for us is it impounds it already embeds the information about the compound frequency, so we don't have to do that work. So it's pretty handy. Now the set of discount factors is called the discount function. So for example, here's a discount function. It's a series of the 6-month discount factor, the 1-year discount factor, the 18-month discount factor, and the 2-year discount factor. And now, and this exhibit's also in 4C1, we'll look at something that maybe just appears to be pretty simple on the surface, and maybe it is, but I do encourage you to stop, pause, work this out with your calculator along with me. Make sure that you're comfortable with what we're about to look at here, because you need to be comfortable with this relationship between between the price of the bond, the discount factor, and the spot rate, because if you're not, then it makes some of the subsequent material just so much more difficult if we gloss over these key foundations or key ingredients or building blocks, I like to call them. So if we have a bond par of 100 and it's 6 months to maturity, and notice in this case the input happens to be the bond price, and it has a coupon rate of 7 7/8. So I've used a Tuckman example, as I usually do. And so what we can do here is extract the discount factor from the fact that we have a bond price. And let me also make a note here that consistently here in Tuckman, right, we're just reviewing Bruce Tuckman chapters, and consistently he's going to be using bonds that pay coupons every 6 months, and so it's natural for us to use a semi-annual compounder discount frequency. So it's always semi-annual here in Tuckman, as opposed to, we also study John Hull in the FRM, and he tends to use continuous compounding or discounting. So just to be comfortable with the compound frequency differences, Tuckman doesn't need to state it every time because it's throughout, and the bonds are paying semi-annual coupon, so we would assume semi-annual discount frequency. But in this case, the bond price is 140, and we have the coupon. So notice that means that in 6 months, we're going to receive, over here on the right, the par of 100 plus half of the coupon. So in this case of the 6-month bond, there's a single future cash flow in this amount. And now, by definition, if we multiply that single future cash flow by the 6-month discount factor, then we should get today's price, which is 101.40 or 101 and 12 3/4 out of 32, or fractionally. So 101.40. See how the price needs to equal the discounted future cash flow. And so that means that the 6-month discount factor is the price divided by the face value plus half of the coupon, or plus the next coupon. And so that means that the 6-month discount factor implied by this market price is 0.97557. And under the law of one price, we ought to be able to use that for any other coupon with the same risk profile, the same exact risk profile that would be received in 6 months. And then we can also, that means given the discount factor, we can also plug that in here and determine 1 divided by this discount factor happens to be only 6 months out, so it's just raised to the 1 power minus the 1, multiply that quantity by 2, and that means that the spot rate associated with this discount factor, see how they're really sort of 2 different perspectives on the same zero or spot rate. This is the 6-month discount factor implied by this zero or spot rate, and vice versa. So it is 5.008% per annum, right? Well, it's a 6-month, but it's a per annum or bond equivalent basis, if you will, for the spot rate. And so that's, you can see there's a relationship here where I have a simple example here of the price of a bond, the single cash flow, face plus half of the coupon rate received in 6 months. But there's a relationship here, a direct relationship between the price, the discount factor, and given the discount factor, the necessarily implied spot or zero rate expressed as a per annum. So definitely hover on that, take out the calculator, work that out if that's what's required to get